Hello.
Yes, sir.
So now the next part is a very important, and that is known as master slave JK flip flop. Okay. So this is the slave master slave JK flip flop. Master slave JK flip flop. In this kind of the circuit is a little but complication because there is one unit block of the master and other unit block of the slave. So first we draw the circuit and then we like to discuss the details. So there are two units, one is master, other is slave. So let us draw the master first. So this is the NAND gate, and here it is the another NAND gate, and these two NAND gates are connected with a clock. This is clock, and the output of these two NAND gates are again connected to the another NAND gate, as we have just discussed about RS flip-flop, and this is latched with this part. Here the latched of this part. So this one is Q1. This is Q1 bar. This is Q1 bar. And this part is master. This part is master with some addition. And the slab part is this output of Q1 is feedback to another NAND gate having this way, and these are connected with the clock point with some NOT gate of this clock. This clock, whatever the, if it is 0, if this is 0, so this point is 1. If it is 1, then this point will be 0 because of this NOT. And the output of this NAND gate is again fed to the NAND gates. These are the NAND gates, and the output of these NAND gates are latched as it is. This is again, this is Q output. Here it is Q bar, the final output. And there is another latched case, that is this output Q. This output Q is taken into as the input of this master. Input of this master we can draw in this way, and this Q bar output is feedback to the input of the master, so that what is going to be output must be well known to the master. And this part of this is known as slave. This part is known as slave. So you see, basic unit are RS flip-flop using NAND gate. So two RS flip-flop NAND gates with addition. What addition is clock? Here it is clock 0 and 1. Here it is the same clock is with NOT gate, means it will, if it is 0, then it is 1. If it is 1, then it is 0. Here it is. So how to briefly describe this circuit as master slave JK flip-flop is a cascaded SR flip-flop, SR flip-flop, RS flip-flop with the feedback from the output of second to the unit input of first block. So these are feedback line. These are feedback line. Here it is the feedback line. This is the feedback in this way. Here it is the feedback in this way with this part, and here it is this part. Feedback block. Now, master is a positive level triggered but due to the presence of the inverter in the clock line, or inverter into clock line, the slave will respond to the negative level triggered. This one say inverter in the clock. This portion is inverter. This portion is inverter. So due to this inverter, this will clock is the negative. Hence, when the clock is equal to 1, positive level, the master is active and the slave is inactive. This is the inactive while the master is active. and vice versa. And vice versa. Vice versa means if the clock is 0, negative level of master is active, the same is inactive. Or slave is active and master is inactive. Vice versa, that is slave is active and master is inactive. Master is inactive. The main of the clock, this is the clock, this part is master, this part is slave. Master, this is slave, this is the high, and here it is low. This is high and this is low. Here it is the clock. High, it is low. Now truth table, if you talk about the truth table of master slave, then the input, output, and we see comment section. So in input, this is E, this is J, this is K, here it is Qn plus 1 and Qn plus 1 bar, and then this is the comment. Now if E is 1, J is 0, K is 0, then these are the previous state, existing state, no change. Comment is no change. And if it is 1, here it is 0, this is 1. So Qn is 0 and this is 1. It is reset. And this is 1. Here it is 1 and K is 0. Then it is 1 and 0. Then it is set. And if all these are 1, this Qn, here it is Qn bar, then this is known as toggle state. This is known as toggle state, indeterminate state or toggle state. So this one is the truth table of master slave flip-flop. Master slave flip-flop. Now, from the operation point of view, if you like to discuss about the operations, then J is equal to K is equal to 0, J is equal to K is equal to 0, and clock is 0. Clock is 0, slave become active, and master inactive. Master is inactive. The second, J is equal to 0, K is equal to 1, and this clock is 1. Clock is 1. Slave become inactive. This is inactive, while master is active. Master is active. Third, if J is 1, K is equal to 0, clock is clock is 1. Clock is 1. Then master is slave become inactive. Master active. Master active with this Q1. Q1 is 1 and Q1 bar is 0. Q1 bar is 0. While in the above case, that is here, it is Q1 is 0 and Q1 bar is 1. So it is opposite of that. And the fourth state is J is equal to K is equal to 1 and clock is equal to 1. So this is known as toggled. Output of master will toggle. Toggle. Output of master, which is active, toggled, and slave inactive. Slave is inactive. And when clock 0, master inactive, while slave is active. While slave is active. So this is about the JK flip-flop. These changed output and returned back to the master inputs. Since clock is 0, the master is still inactive. So it does not respond to the changes. This avoids the multiple toggling. This avoids the multiple toggling, which leads to the race around the conditions. Race around the conditions. The master slave flip-flop will avoid the race around the condition. So these are the important points that what is the state of the clock. If clock is 0, master is inactive, ray slash is active, and vice versa. And if both are one state, then it is toggling. And to avoid the multi-toggling, which leads to the race around the conditions, the master slave flip-flop will avoid the race around the given condition. So this one is the complete discussion of this master slave. Now, if we have to avoid these things, then we use the delay flip-flop. Delay flip-flop, it is also called as D flip-flop. D flip-flop or T flip-flop. The next point is toggled flip-flop. The delay flip-flop is something like this is the two NAND, and these two NANDs are connected with this one. The important point is this NAND is converted with the inverter. This NAND is converted with the inverter. That is, this is the we have a clock. Here it is D input, and this output is fed to the another NAND, and here it is the latched circuit. This is the NAND latch circuit. This point is Q. This point is Q bar. So this is NAND 1. Here NAND 2. This is NAND 3. This is NAND 4. And this is the R dash, and this is S dash. The new input is. So this circuit can be expressed in terms of block, and the block circuit is something like this. It is D, something like this. It is clock, and here it is Q, and this is Q bar. So this is the block diagram. This is block diagram, and this is the circuit diagram. So briefly, we can describe D flip-flop. D flip-flop is the simple gated RS latch with the NAND inverter connected between two inputs S and R. So this is the This is the inverter NAND. This is the inverter NAND. It has only one input. It has only one input. The input data is appearing. The input data is appearing at the output on the same line. Due to this, data delay between input and output it is called data delay flip-flop. Data delay flip-flop. S and R will be the complements of each other due to NAND inverter. Due to NAND inverter means this is complement to this. Both NAND 3 and 4 has complementary inputs. Hence, S is equal to 0, which is R. S is equal to R is equal to 1. These input conditions will never be there. Never be there because of the complement, because of inverter NAND. Because of the inverter NAND. So the truth table of D flip-flop is given as inputs, outputs, and comment. This is E, it is clock. This is D, this is Q n plus 1. This is Q bar n plus 1. So you see, if it is clock 1 and this D is 0, D is 0, so it is Q1 is Qn plus 1 is 0, and here it is 1, and then it is known as reset. Clock is 1, D is 1, this is 1 and 0, then it is called at set. Then it is called a set point. Then it is called at set point. The operation of this is operations. First, when clock E is 0, latch is disabled. Latch is disabled. That is no change in output. No change in output. Second, if E is equal to 1 and D is equal to 0, D is equal to 0, then S is equal to 0 and R is equal to 1. Hence, irrespective of present state, the next state is Qn plus 1 is equal to 0 and Qn plus 1 bar is equal to 1. That is reset. That is reset. The third is E is equal to 1 and D is equal to 1. Then S is equal to 1 and R is equal to 0. R is equal to 0. This will set the latch. This will set the latch. This will set the latch, and Qn plus 1 is Qn plus 1 and Q bar n plus 1 is equal to 0, irrespective of present state, and therefore it is known as set. Therefore it is known as set. So these three cases are for the D flip-flop of the case, and the last one is toggle flip-flop. It is also known as T flip-flop. T flip-flop. It is also known as T flip-flop. So toggle flip-flop is basically a JK flip-flop with J and K terminals permanently connected together. Permanently together. So it has only one input denoted by T the symbol for positive edge triggered positive edge triggered T flip-flop edge. This is the block. This is the block. This is T. This is E. Here it is Q. This is Q bar. So these are the two inputs. Here it is the two outputs. These are the two outputs. And the block diagram is something like J, K, E, Q, Q bar. This way. Now the truth table. Now the truth table is, you see input, output, comments. E is equal to 1 and E, T, Q, N plus 1, Q bar, N plus 1. So E is 1, T is 0, this is Q, N, this is Q, N bar. If it is 1,